With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
So here's the question is, two identical solid cylinders are released from the top of two inclined plane. It means two identical solid cylinders are released from the top of the inclined plane of equal angle. If one cylinder is pure rolling and other is pure sliding, then the motion is what? We have to find the motion when one solid cylinder is in pure rolling motion and one is in pure sliding motion. Okay, and we have to find which cylinder reached bottom later and which cylinder is come faster. Okay, so when the cylinder is in sliding, so first let's draw the inclination. Plane be like this. Let's suppose this is the cylinder. Okay, this is the cylinder and the center is O. So the component of forces be like this. Here, when the cylinder is sliding, there is no friction and no torque is there. Here we can say case 1. Okay, here we can write when cylinder is sliding. Okay, so here the component will be like mg cos theta and this component is mg sin theta. Okay, so these were the two components. So the equation will be equal to mg sin theta is equal to ma. Okay, and the other equation is a is equal to g sin theta. Here a is the acceleration in which the cylinder is moving in downward direction. This is a acceleration. Okay, now when we talk about case 2, when the cylinder is rolling. Okay, so the diagram will be like this. This is the cylinder and here when the cylinder is rolling, then there will be some frictional force is act there, is F. Okay, and also here having torque for rotating the cylinder. Okay, so the component will be like this direction, and here this n mg cos theta and this component is mg sin theta. Okay, so here we can write the expression is mg sin theta minus frictional force is equal to ma dash. Let's suppose that acceleration of rolling cylinder is a dash. Okay, so here we got this equation. Let's suppose this equation number 1. Okay, now when we talk about the torque of the rolling cylinder, torque will be, when we talk about the torque, we know that torque is equal to R into F, where F is the frictional force here and here R is the radius of cylinder. R vector is the radius of cylinder. Okay, so here, and also we know that the magnitude of torque will be equal to magnitude of R, magnitude of F, and sine theta. Here sine theta is equal to 90 degrees, means the value of sine theta is 1. Okay, because here we know that angle between them is 90 degrees. The value of theta is 90. So the torque will be equal to, here R is equal to the radius of cylinder, and here force is frictional force. And also we know that the torque is equal to I alpha. Here I is the inertia when the cylinder is moving in this direction. Here inertia is also working. Okay, so here we can write this equation as Rf is equal to mr square by 2, because here in this situation the inertia is equal to mr square by 2. mr square by 2. Here m is the mass of cylinder and r is the radius of cylinder into alpha. Okay, now when we solving, r is cancelled by r square, so here frictional force is equal to mr alpha by 2. Okay, let's suppose this equation is 2. Now, and the condition for the pure rolling is velocity is equal to omega r. So this is the condition for pure rolling. Okay, so when we derivative this part with respect to time, we got the expression dv by dt is equal to r, here small r is equal to radius, and d omega by dt. Here this expression is equal to alpha. Okay, so and we know that dv by dt is equal to acceleration, so here a dash. Here we know that the acceleration of this rolling cylinder is a dash and the sliding acceleration of this cylinder is a. Okay, now here we got our expression a dash is equal to r alpha. Okay, now using equation 2, now when we using equation 2, so we got f is equal to m a dash by 2. Okay, now when we using equation 1, then we got the equation is mg sine theta minus ma dash by 2, because here this is equation 1 and we just putting the value of frictional force. Okay, now it will be equal to ma dash. Okay, so the value of a dash will be equal to 2g sine theta divided by 3. Okay, and we know that the value of a will be equal to, and we know that the value of a is g sine theta. This is the acceleration of the sliding cylinder. Okay, so here we conclude that the a dash is smaller than a. Okay, which means the acceleration is greater in sliding. It means the sliding cylinder is reach first. Okay, So here option B is correct. The rolling cylinder will reach the bottom later with lower speed. Okay, that's it. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.